On the final page, we're looking at some Pythagoras and some fractions and some algebra work. So first of all, some Pythagoras. So I need the perimeter of the triangle. The thing that's really missing is this length AB. But to get that, I'm going to need the length BD. So I'm going to use this triangle BDC. And I know these two lengths. I'm not finding the hypotenuse, so I know it's going to be a subtraction. And so I'm going to do the square root of 5 squared, take 3 squared, which indeed is 4. Actually, it's a 3, 4, 5 Pythagorean triple for what it's worth. I'm going to write that on the diagram, so I've got it there. Now I'm going to use the triangle BDA. I've got 7 and 4. This time I am finding the hypotenuse, so I'm going to be adding. So that's the square root of 65. I'm going to leave it in exact form for now. The question doesn't really specify, but I'll leave it in exact form for now. So I've got to go back then and say, what was the question actually asking me to do? It was asking me to find the perimeter of this shape. So I'm going to have to add all these side lengths together. So 7 and 3 and 5 and root 65. So the perimeter is going to be 15 plus root 65 feet, as specified in the question. And I'm going to write that in decimal form. It's 23.06 feet to 2 dp. Because the question doesn't specify otherwise, exact form would be perfectly satisfactory. Question 6 is asking whether this triangle is right-angled. To answer this, we need to decide whether Pythagoras' theorem works with these lengths 5, 11 and 12. So I'm going to get all of them squared. I'm going to say, do these two add up to the third one? 146 is obviously not 144, so it is not right-angled. So the sum of the two smaller squares is not equal to the larger square. Question 7, we've got some fairly sort of hardcore algebra stuff going on. So let's think about this. I've got a square with side length 3 and 3/5, and I'm taking out a rectangle with side lengths 1 1/4 and 2 2/3, and I want to know what's the white space left. So I'm going to do, well, I'm going to do 3 3/5 squared, and I'm going to subtract whatever 2 2/3 multiplied by 1 1/4 is. So I think I better change these to top heavy fractions. It becomes 18 over 5 squared. Take away 8/3 times by 5/4. A fairly monstrous common denominator. It's going to be 25 12s, which is going to be 300. 12 324s. Oops. 3 8 8 8. 25/40s I think I can probably do. And I'm just going to put centimetre squared. It does cancel down a little bit. I can see there's a factor of 2 there. There's no requirement in the question to change it to mixed number, so I think I'm just going to leave it like that. For question 8, a bit of fraction simplifying. Remember, the principle is we don't cancel anything from a fraction like this unless it's a factor. And because we've got these two subtractions, nothing there immediately is a factor. So I need to factorise top and bottom. Highest common factor on the top is 2. Gives me n minus 2 in the bracket. Highest common factor on the bottom is 3. Conveniently also gives me n minus 2. So I can cancel these two n minus 2's, and the simplified fraction becomes 2/3. For part B, I'm actually going to change that x squared just for the sake of being very demonstrative. I'm going to change it to xx. And think about what can be cancelled. So I'm going to cancel a factor of 2 here, cancel that with a 6 here, and I'm going to cancel one of these x's with one of the ones up here. And we can see on the top that gives us 3 times 3x, and on the bottom it just leaves us with 5. So 9x over 5 is going to be our final answer there. And finally, x plus 5, x minus 5. I put in as a sort of extension thing, I suppose. We'll multiply everything in the first bracket by everything in the second. We'll do more of that later this year. So I'm going to do x times by x. I'm going to do x times by minus 5. I'm going to do 5 times by x. I'm going to do 5 times by minus 5. And then I'm just going to collect like terms. I can see that the minus 5x and the plus 5x are going to cancel each other out, just leaving me with x squared minus 25. If you're interested, that's an example of what's called the difference of two squares.